In this video, I want to prove this relation in three different methods. Two of the methods is based on trigonometric relations and identities, and one method is based on the calculus. Suppose the angle tangent inverse of x alpha and suppose cotangent inverse of x beta. Remember that the tangent inverse of any number like x is an angle. For example, tangent inverse of 1 is pi over 4. So we suppose tangent inverse of x angle alpha, and we suppose cotangent inverse of x angle beta. These are two angles, and we want to prove that sum of these two angles. So our aim here is to show that alpha plus beta is pi over 2. So we want to prove this relation because alpha is tangent inverse of x and beta is cotangent inverse of x. Because alpha is tangent inverse of x, immediately from this relation we conclude that the tangent of angle alpha is x. And because beta is cotangent inverse of x, so cotangent of angle beta is also x. Now for angle alpha and angle beta, let's draw right triangles. So suppose this is angle alpha and this is another triangle for angle beta. Tangent of alpha is x, and we know that the tangent of an angle is opposite over adjacent. So in this triangle, the opposite side to alpha is x and the adjacent is 1. We can use the Pythagorean theorem for finding the length of the hypotenuse. If you remember Pythagorean identity, a to the 2 is 1 to the 2 plus x to the 2. This is Pythagorean theorem. A to the 2, the hypotenuse to the 2 is 1 to the 2 plus x to the 2. From this relation, a, the length of the hypotenuse, is radical 1 plus x to the 2. So this side is radical 1 plus x to the 2. Now for this triangle, we have the length of the all sides. Let's do same thing for angle beta. Cotangent of beta is x, and cotangent is a reciprocal of tangent. Tangent is opposite over adjacent, but cotangent is adjacent over opposite. So x over 1, the x is adjacent. So in this triangle, the adjacent side is x and the opposite is 1. So in this triangle, the cotangent of beta is x over 1. Similar to the triangle that we had here, we can see that the length of the hypotenuse by the Pythagorean theorem is radical 1 plus x to the 2. Now that we have completed our triangles or right triangles, these are right triangles, let's start proving that alpha plus beta is pi over 2. But before that, let me remind you something. Sine of pi over 2 is 1. So if we can prove that sine of alpha plus beta is 1, then from this we can conclude that alpha plus beta is pi over 2. But we need other details which I will explain later. When sine of an angle is 1, not necessarily we can conclude that that angle is pi over 2, because we have other angles that the sine of those angles is also 1. We need other details for this conclusion, which I will explain later. So we want to prove that sine of alpha plus beta is 1. So let us start proving this here. Sine of alpha plus beta is 1. Let me remind you a relation that we have for sine of alpha plus beta for sum of the angles. If you remember, sine of alpha plus beta is equal to sine of alpha plus beta is always equal sine of alpha, cosine of beta plus cosine of alpha, sine of beta. We have this relation for the sum of the angles. This is a formula from trigonometry. We want to use this formula to prove that sine of alpha plus beta is 1. Look at these triangles that here we have and find sine of alpha. Sine of alpha, sine of this angle, is opposite over hypotenuse. So sine of alpha is x over radical 1 plus x to the 2. So x over radical 1 plus x to the 2 is sine of alpha. What about cosine of beta? Cosine of beta, if you look at this, cosine is adjacent over hypotenuse, and so it is x over radical 1 plus x to the 2. It is the same as sine of alpha. Now we have to find cosine of alpha. Look at this triangle. Cosine is adjacent over hypotenuse, so cosine of alpha is 1 over radical 1 plus x to the 2. 1 over radical 1 plus x to the 2. And sine of beta, sine is opposite over hypotenuse, and it is 1 over radical 1 plus x to the 2. So sine of beta is 1 over radical 1 plus x to the 2. Let's simplify this expression. For these fractions, if we multiply this by this, x times x is x to the 2, and radical times radical, the radicals cancel each other. So in numerator we have x to the 2, and in denominator we have 1 plus x to the 2. For the other one we have 1 over 1 plus x to the 2. If we add these two fractions, the denominators are the same, so we can simply add numerators. So we have x2 plus 1 over 1 plus x to the 2. Numerator is the same as denominator, so this fraction equals 1. So we have proved that sine of alpha plus beta is 1. When sine of an angle is 1, one possible answer for that angle is pi over 2. Let me remind you something here. Sine of pi over 2 is 1. But sine of 5 pi over 2 is also 1. Sine of negative 3 pi over 2 is also 1. Because all of these angles show same point here. This angle is pi over 2. But if we rotate and we back to the original point, we have 5 pi over 2, and sine of 5 pi over 2 is also 1. So here we cannot immediately from this relation, we cannot conclude from sine equals 1, we cannot immediately, without giving reason, conclude that this angle is pi over 2. We have to give reason for that claim. Attention, alpha is not a random angle. Alpha is tangent inverse of x. Let me remind you something about tangent inverse of x. Tangent inverse of x is the inverse of the tangent function. But we know that tangent has no inverse because tangent is not a one-to-one function. When a function is not one-to-one, it has no inverse. So how come the tangent inverse is the inverse of tangent? Because in math, we limit the domain of the function tangent to between negative pi over 2 and pi over 2. When we limit the domain of the tangent between negative pi over 2 and pi over 2, we name the inverse of this function tangent inverse. So what do I want to say here? I want to tell you tangent inverse of x, which is angle alpha here, is an angle between negative pi over 2 and pi over 2. So tangent inverse of x is defined between, not equal, between negative pi over 2 and pi over 2. This is the way that we have defined tangent inverse as the inverse of the function tangent. So we know something about alpha. We know that this angle alpha is between negative pi over 2 and pi over 2. For angle beta, we know that it is between 0 and pi. For similar reason, we have limited the domain of the function cotangent between 0 and pi. So the range of the function cotangent inverse, which is beta, is between 0 and pi. So angle alpha, please attention, angle alpha is between negative pi over 2 and pi over 2. Angle beta is between 0 and pi. If we add these two inequalities to each other, what we can conclude about alpha plus beta? By adding this relation and this relation, we have this condition for alpha plus beta. Because alpha is between negative pi over 2 and pi over 2, beta is between 0 and pi, so alpha plus beta would be between negative pi over 2 plus 0 would be negative pi over 2. Pi over 2 plus pi is 3 pi over 2. In this region, between negative pi over 2 and 3 pi over 2, please attention, in this region, the only angle alpha plus beta that its sine is 1, the only angle that has this condition in this region is pi over 2. Other angles like 5 pi over 2 or 9 pi over 2 or negative 3 pi over 2, these angles are not in this region, so we reject them, because we know that the angle alpha is between negative pi over 2 and pi over 2. Angle beta is between 0 and pi, so their sum cannot be something like 5 pi over 2. It's only possible, the only possible value for alpha plus beta is pi over 2. And this completes our proof for this relation. So we have proved that tangent inverse of x plus cotangent inverse of x is pi over 2, or arctan of x plus arccotan of x is pi over 2, because alpha is this and beta is this. So these details in this proof are really important. If you forget any of these details in your proof is not complete. The other thing that I have to add to my proof here is that in this triangle that we draw here, x in this relation, x can be any real number. It can be positive or negative. So this side, which I named it x, this x value is not necessarily a positive number. It can be also a negative number. This is something that I have to mention in my proof, that you consider this here. Now let me show you another proof for this relation. So we want to prove in another method why tangent inverse of x plus cotangent inverse of x is pi over 2. So we want to show that arctangent of x plus arccotangent of x, or tangent inverse of x plus cotangent inverse of x, is pi over 2. Here I will show you another way for proving this with the aim of trigonometric relations. The relation that I want to use here to prove this identity is this relation. Cotangent of theta is tangent of pi over 2 minus theta. This is a relation between cotangent and tangent. Cotangent of any angle like theta is always equal to tangent of pi over 2 minus theta. If you don't know this relation, I will prove for you this relation at the end of the proof. For now, accept from me this relation. I want to use this relation for proving this relation here. At the end of the proof, I will show you a reason. I will prove for you this relation also. So we want to use this relation, but how? We want to use this relation. Here, let's suppose arccotangent x as angle theta. So we suppose theta arccotangent of x. Immediately from this, we can conclude that the cotangent of angle theta is x. Because cotangent is the inverse of arccotangent, so cotangent of angle theta is x. Now, please attention. Now we want to use the relation. Because cotangent of theta is x, and also cotangent of theta is equal to this. This is always true. So by combining these two relations, x is cotangent theta. Cotangent theta equals this, so we can conclude from this x equals tangent of pi over 2 minus theta. So from this relation, and from this relation we can write this, because x equals this and this equals to this, so x equals to that. Now this is the important part of the proof. Now from this relation I want to conclude that tangent inverse or arctangent of x is pi over 2 minus theta. Please attention, not for any angle from this relation you can conclude, you can ignore, you can inverse the tangent and write arctangent in the other side. Not for any angle. From this relation, if we want to conclude this relation, the condition that from this relation we can conclude this relation is that the angle that here you have should be in the between negative pi over 2 and pi over 2. So let me repeat this part because this is a little confusing. If you have tangent of an angle, let's say tangent of angle beta equal a number like a, not always you can conclude that beta is arctangent of angle A. This relation, this conclusion, not for any angle is true. You cannot conclude this relation from that relation for any angle beta. Because attention, arctangent is inverse of the tangent function if the angle beta is between negative pi over 2 and pi over 2. If we have this condition, yes, from this relation we can conclude this. So now I have to show that this angle, which is here, is between negative pi over 2 and pi over 2. If I can show this, then this completes my proof. And then it means that from this relation, I can write this. Otherwise, this is not right. Please attention. The theta angle that here we have is arccotangent of x. But what we know about arccotangent? Please attention. We know that theta is arccotangent of x. We suppose arccotangent of x as angle theta. We know that arccotangent is always between 0 and pi. Now, let's multiply both sides of this relation by a negative, because we have a negative theta here. By multiplying both sides of this inequality by a negative, then we have negative theta is between negative pi and 0. Don't forget, when you multiply inequality by a negative, you have to flip the inequalities. So negative of theta is between negative pi and 0. Now we want to make this angle pi over 2 minus theta. So we have to add pi over 2 to the left side, pi over 2 to the middle, and pi over 2 to the right side. By adding pi over 2, we get this relation. Pi over 2 minus theta is between. If we add pi over 2 to negative pi, it would be negative pi over 2. And if we add pi over 2 to 0, it's pi over 2 here. So this is angle theta here. So look at this. Now we have the condition that we need. If we want to get from this relation to this relation, we have to know that this angle is between negative pi over 2 and pi over 2. Now we have proved that this angle is between negative pi over 2 and pi over 2. So from, let me name this relation 1 and relation 2. From 1 and 2, by considering these two relations, we can conclude that arctangent of x is pi over 2 minus theta. Now look at this. We are almost done for our proof. Please attention. Here we know that arctangent of x is pi over 2 minus theta. Here we know that theta is arccotangent of x. Now let's add this to this, and let's add this to this side. So let me name this relation number 3, and let me name this relation number 4. By adding relation number 3 to relation number 4, we have arccotangent of x plus arctangent of x is theta plus pi over 2 minus theta. Theta plus pi over 2 minus theta is pi over 2, because theta with negative theta cancels. So we have proved that arctangent of x plus arccotangent of x is pi over 2. And this completes our proof. Before I show you the next method for proving this relation, this identity, let me show you by an example why not for any angle from a relation like this we can conclude this relation, not for any angle. Let me show you an example. For example, we know that tangent of 3 pi over 4 is negative 1. Because reference angle for 3 pi over 4 is pi over 4, and tangent in second quadrant is negative, tangent of 3 pi over 4 is negative 1. You can check this also by a calculator. From this, if we want to write such a relation, can we conclude that arctangent of this number, negative 1, is equal to this angle, 3 pi over 4? Is this relation right? Is arctangent of negative 1 3 pi over 4? If you put arctangent of negative 1 in a calculator and calculate this, you would see that this equals pi over 4 or 45 degrees. But is this equal to 3 pi over 4? No. So your conclusion is wrong. Not for any angle we can reverse function tangent and change it to arctangent. Because arctangent, please attention, these are important things that you should understand in math. Arctangent is inverse of function tangent only in a specific region, in interval, in some interval. What is that interval? Negative pi over 2 to pi over 2. Outside of that region, it's not the inverse of the function tangent. Okay, let's move to the next proof. So now I want to show you in another way why arctangent of x plus arccotangent of x is pi over 2. Now we want to prove this in another method. Here I use the knowledge from calculus. If you are not familiar with calculus, you can ignore this last proof. You can use the other proofs to prove this relation with the aim of trigonometric relations. Let's suppose this expression in the left side, f of x. So we define a function and we name that function arctangent of x plus arccotangent of x. Here we have an expression. We name this expression f of x. So we have defined a function. Now that we have a function, if you remember from calculus, we have an operation, an important operation in calculus, derivative. Let's find derivative of this function. You will see the reason that I am taking derivative of this function. I have a good reason for taking derivative. Derivative of arctangent of x based on derivative rules is 1 over 1 plus x to the 2. And the derivative of arccotangent is negative of 1 over 1 plus x to the 2. 1 over 1 plus x to the 2 minus 1 over 1 plus x to the 2 is 0. So derivative of the function f is 0. But if you remember from calculus, only derivative is 0 when we have a constant. For example, derivative of number 4 is 0. Or derivative of negative 1 is 0. Or derivative of radical 2 is also 0. Or derivative of pi over 2 is also 0. Derivative of any constant is 0. But if a function, the value of a function changes, its derivative is not 0. But now we know that derivative of the function f is 0. Because derivative of the function f is 0, so because f prime of x is 0, from this we can conclude that the function f of x is a constant, because only derivative of constants is 0 and derivative of f is 0. So this means that the function f of x, which is this expression, is always equal to a number. Its value doesn't change. X changes, but the value of this function doesn't change. So because f prime of x is 0, we conclude that f of x is always a constant. So far we have proved that, please attention, so far we have proved that arctangent of x plus arccotangent of x is always a constant, like c. But what is the value of c? C can be any number. It's a constant. Maybe it's 1, 0, negative 1, pi, 2 pi, pi over 2. We don't know that number. But it is a fixed number. It doesn't change. For finding c, simply you can substitute a random value for x. Calculate the value of this, and then you can find the value of c, because it's always the same. We know that the value of arctangent of x plus arccotangent of x for any value of x is always a constant c. For finding that c, simply substitute a random value for x. For example, let's substitute 0 for x. By substituting 0, we have arctangent of 0 plus arccotangent of 0. Arctangent of 0 is an angle that its tangent is 0. The angle that its tangent is 0 is 0. Don't forget, we have other angles that their tangent is 0, like pi, or 2 pi, or 3 pi. But because the range of the tangent inverse or arctangent is between negative pi over 2 and pi over 2, between negative pi over 2 and pi over 2, the only answer for arctangent of 0 is 0. What about arccotangent of 0? What is the angle that its cotangent is 0? Pi over 2. 3 pi over 2. 5 pi over 2. But remember, arccotangent is limited between 0 and pi. In this region, the only angle that its cotangent is 0 is pi over 2. So 0 plus pi over 2 is pi over 2. So this means that this unknown c is pi over 2. So we have proved that. Let me erase c from here and substitute c with pi over 2. So we have proved that arctangent of x plus arccotangent of x is pi over 2. Maybe here by yourself you are thinking, what if I substitute another value for x? Maybe the value changes, then c is different. No, remember, we proved that the derivative of the function f is 0. When the derivative is 0, the function is always a constant, so its value doesn't change. If you change the value of x, it doesn't matter. At the end, always the output of the function is always the same. Let me show you. For example, suppose you substitute 1 for x. Then you have arctangent of 1 plus arccotangent of 1. What is the angle that its tangent is 1? Pi over 4. What is the angle that its cotangent is 1? Again, pi over 4. Pi over 4 plus pi over 4 is pi over 2. So as you can see, it doesn't matter. If you plug in other numbers for x, always you can see that the answer is always same value. So this is another way for proving this important relation between tangent inverse and cotangent inverse. I hope you like this video. If you like this video, please subscribe in my channel and see you in the next videos.